Hello all. Welcome to the week 2 interaction session of the course Wastewater Treatment and Recycling. Session is supposed to start at 7 p.m. But let us wait a couple of minutes more so that our other friends can also join this discussion. So we will start the discussion after 2 to 3 minutes.
Okay.
Okay, I guess we can start the session now. So I will introduce myself now. I am Sethulekshmi, third year PhD student, PMRF Prime Minister's Research Fellow from Environmental Science and Engineering Department, IIT Bombay. So today I will be taking an interaction session for week 2 lectures which have been uploaded in the NBTL course page for the course Wastewater Treatment and Recycling. This interaction session is aimed to focus on discussion of some of the questions and answers, and it is meant for like for your doubt clearance. And I hope this session, as we discuss many questions in this session, I hope this will be useful for your for solving the assignments as well as for the exams of this course as well as for other competitive exams. So that's a quick brief introduction about this session, and I guess some of our friends are still joining, but I shall share the screen now. And also one of the important announcement is that on the last interaction session which happened last week, some of you have asked me a doubt that for this course about the final exam, whether it will be subjective or objective. So I have asked about this to the concerned authorities, and it is being said that the exam will be objective in nature, not subjective. So kindly note that. So let me share my screen. I hope my screen is visible to you. Let us start the session. If there is any problem, like if I am not audible or if the screen is not visible, kindly let me know. As I have said before, this session is for week 2 lectures which have been uploaded in the NBTL course page, and for the course Wastewater Treatment and Recycling, and this is hosted by me. I am Sethulekshmi. I am a Prime Minister's Research Fellow in Environmental Science and Engineering Department of IIT Bombay. So today this session please consider as a discussion forum, and if you have any doubt or anything related to the week 2 lectures which have been uploaded for the course, you can discuss here, and we will be discussing a few questions including numericals in this session in this 1 hour time, and this will be beneficial for solving the assignment questions as well as for the final exam of this course. I guess some of the friends are still joining, so let me admit them and then let us come back to the session. Okay, let us come back. So, coming to the first slide, let us first discuss about what we have discussed or what you have learned in the week 2 lectures of NBTL lectures for the course. So I guess all of you have seen the lecture videos. If not, kindly go and watch the videos, and kindly see the lecture notes today itself. So like on a brief note, these are the like I'll be discussing the brief overview of what you have learned in week 2. So, in the course, you have learned about the sources of wastewater generation or sewage generation. Then you have seen what are the methods for population forecasting, because you have also seen why population forecasting is done. Primarily because in order to design any sewer network or a sewerage system network, we need to know what is the population which is intended to serve. So for that purpose, we have different methods, scientific or different methods which are well described for forecasting population in a particular year or a decade or after a particular decade. So different methods were seen in this. I hope all of you know what are the population forecasting methods. And then you have learned about how to estimate quantity of sewage generation of a particular city with particular amount of population. So that also we have seen in the week 2 lectures. Then you would have come across some of the practice problems which were already discussed with the lecture. So that was also done. And then there was a brief discussion of what is the status of wastewater generation and treatment in our country. So all these things were seen in the week 2 lectures. So with this information or as a background, let us solve a few questions from this week 2 nptel lectures. So before that, I guess somebody is still joining, so please pardon. I'll just quickly admit them. So let us come back. Let us discuss the first question. Basically, I need all of your participation here. So once the question is asked, all of you please try to solve it, and also try to respond back. You can either comment your answer in comment box, or you can tell that you can say out the answer. So anything is possible. So first question is, municipal wastewater quantity estimation is done based on option A, number of inhabitants and water use practices, option B, precipitation, option C, number of industries in the area, option D, irrigation supply. So anyone, any guess or any answer for this? You can say out loud, no problem for that.
Option A.
A option.
Option A. So any other guesses or any other lead on this?
Maybe it will be C.
Okay, could you please explain why C is an important option compared to others?
See, in my opinion, I think that in option C, means companies are there for the polluting the area. So better it will be means contaminate the water. So that is the main reason for that.
Okay, fine. So let us see the answer first. Okay, the answer is option A, number of inhabitants and water use practices. So let us see why it is option A. Uh, like the question is, municipal wastewater quantity estimation is done based on. Obviously, these all are four factors which are affecting the wastewater quantity of a municipal region. But always, when we do as engineers, when we do the estimation, we consider number of inhabitants and water use practices in that area to design what is the or to estimate what is the wastewater quantity. So option A is the correct answer. The precipitation also could affect, that is also there, number of industries in the area could also affect the municipal wastewater quantity generation. But for estimating the quantity, we always go for number of inhabitants and water use practices. Therefore option A is the correct answer. I hope it's clear for all of you. If there is any doubt, you can ask. Otherwise, we'll move to next question.
Yeah, now it's clear.
Okay, thank you. So let's move on to next question. I guess some of your friends are still waiting in the lobby, so let me quickly accept them also. Sorry for the delay. So let us move on to the next question. So next question is, combined sewers are designed to carry option A, stormwater runoff and municipal wastewater, option B, municipal wastewater and industrial effluents, Option C, agricultural runoff and municipal wastewater. Option D, stormwater runoff, municipal wastewater and agricultural runoff. So, any lead on this?
Option A, ma'am, I guess.
Option A. Yes. Let us see the answer first. Yes, option A is
Ma'am,
the
option A.
yes. Option A is the correct answer. Very good. Because see the combined there are two type of sewer networks. I think you would have learned about it in the lecture videos. It is you have combined sewers where you will have two type of flows are there: stormwater runoff and you have municipal wastewater. So when we design a sewer network to incorporate both stormwater and municipal wastewater in a municipal region, then that is known as combined sewers. So anyone know what is the other type of sewer network which we have other than the combined sewers?
Separate sewers.
Separate sewers. Yes, that is correct. So we have other than combined sewers, we also have designed systems separately to incorporate municipal wastewater as well as stormwater. So these are the two type of sewers. So what are the other options? Let us see. Option B is municipal wastewater and industrial effluents. But industrial effluents, industrial effluents, when we take it, there is a possibility that these could be discharged into the sewer lines, but in effect, it is not considered as a separate parameter for the design. So for the design we consider two type of wastewater, that is stormwater runoff and municipal wastewater, and if it is going in a combined system it is called as combined sewers. Similarly with agricultural runoff and for agricultural runoff could also go into the sewer lines, but as engineers when we design we basically consider these two types, stormwater runoff and municipal wastewater. So I hope it is clear for you. So let us move on to the next question.
Ma'am, there is a doubt.
Yes.
In many textbook, there is a saying that stormwater and agriculture runoff, they are both same. They have taken both together,
Yes.
and sir have taught they are separate.
Separate.
So,
Yes. Yeah. So I will tell the reason. See, stormwater runoff means like if you have a municipal region and like if you have if it is a rainy season, if it's a wet weather season, if you have the runoff from that region, it is called as stormwater. So that can be called as a stormwater runoff. But agricultural runoff generally refers to, like, particularly it need not be a wet weather season. It could be a dry weather season also. But if you have an agricultural field with you have a lot of agricultural activities going on, use of pesticides, use of manures, etc. And other things, other agricultural activities going on in an area, and obviously there would be some runoff, some amount of wastewater which is getting generated from that region. So that is in particular known as agricultural runoff. So this is the difference between these two. I hope it's clear for you now.
yes, ma'am. Yes, ma'am. Thank you.
Yes, thank you. So let us move on to the next question. I guess a few of your friends are still waiting in the lobby. So kindly pardon me for accepting them also. Let us come back to the third question. Which of the statements are true? First option is dry weather flow depends on weather conditions and infiltration in the sewers. B, dry weather flow undergoes fluctuations. C, combined sewers carry stormwater runoff and municipal wastewater. Option D, all the above. So, any answers, any guess, anyone?
Option D, ma'am.
Option D, which one?
Option C.
Option C, okay. Let us see the answer first. The correct answer is option D, all the above. The question is which of the following statements are true. So let us see the first option. Dry weather flow depends on weather conditions and infiltration in the sewers. So this statement is correct because you know what is dry weather flow, right? When the weather is dry, when it is not a rainy season, whatever flow is coming through the sewers, it is known as dry weather flow. So obviously it depends on the weather conditions, and also there could be some infiltration into the sewers which we should account for. I think you have learned about this infiltration thing in the like additional flows into the sewers topic in this week 2 lectures. So in effect this statement is true. And then let us see what is option B. Option B is dry weather flow undergoes fluctuations, which is also a correct statement because based on the use pattern, based on the characteristics of the population and other things, based on the variations in the infiltration, everything. So this dry weather flow can undergo fluctuation. So this statement is also correct. Option C is combined sewers carry stormwater runoff and municipal wastewater. That is a true statement. We have seen it in the last question. So that is also true. So all the statements are true. So the answer is D, all the above. So I guess it's clear for you now. So let us see the next question now. The fourth question is design period of a sewer system is based on option A estimated population, option B area of the city, option C useful life of the sewer system components, option D all the above. So any lead on this?
Option D, ma'am.
Option D, okay. Any other choices?
Option D, ma'am.
All right. Anything else? Okay, let us see the answer. The answer is option C, useful life of the sewer system components. So let us see why it is so. We have seen in the lecture that for designing a sewer system, the most important parameter we have to see is the first is the useful life of the sewer system components. So basically design period is based on design period is always based on the life of sewer components. CPHO manual has given a few like this table is also given in your lecture notes, in which they have given the life period of different sewer components. So based on these values we decide the design period of a sewer system. So the area of the city, then this estimated population, all these are coming in picture when we design what is the quantity of sewage which is to be treated in the designed treatment system. The design period is always based on useful life of the sewer system components. So I hope it is clear now. If you still have the doubt, kindly refer to the lecture notes. as well as there is a separate I think lecture 2 or 3 in which the professor has discussed about the design period of a sewer system. So any doubt on this?
Ma'am, what is the life of sewer pipeline?
Sewer pipelines, that I am not sure about it now. So I guess it is also given in this manual. So you can refer to this. Otherwise, I will clarify it in the next class.
Okay, ma'am.
It's all based on the manual, which this manual is what we follow for knowing the life period of different components.
Hmm.
So any other doubt? If not, let us move on to the next question. The next question is which of the following population forecasting method assumes percentage population growth rate as a constant? Option A, arithmetic increase method. Option B, geometric increase method. Option C, incremental increase method. Option D, none of the above. So any guesses? Which of the following population forecasting method assumes percentage population growth rate as a constant? Any lead, anyone? You can always guess, it need not be correct. Since it's a discussion forum, you can always tell or
Option B,
express
ma'am.
yourself.
I guess geometric increase.
Option B,
Option
okay.
B.
Then, any other guesses? Okay, let us see the answer then. Yes, that's correct. Very good. Answer is option B, geometric increase method. In the geometric increase method, as you have seen in the lecture videos, it is assumed that the percentage population growth rate is a constant. The formula is P is equal to P naught into 1 plus R raised to N. So this rate is assumed as a constant. So this N is the like
Number
number
of
of,
years.
yes, number of years. So this R is assumed as a constant. And this geometric increase method could be applied, or it could give good results for new cities where there is a massive scope of expansion. Because as you would have seen in the lecture video that in the lecture video the professor had solved same problem, same numerical, with arithmetic increase method, geometric increase method, and incremental increase method. And we have seen that in the geometric increase method, the estimated population was very high. So it means that compared to these three, geometric increase method gives very high estimation of population. So it could be applied to new cities where there is a massive scope of expansion. So this is all about this question. Any doubt on this? If there is no doubt, we will move on to next question.
Yeah, ma'am, there is a one question.
Yes.
Generally, ma'am, which method we use for to estimate the capacity of the sewage treatment plant?
Capacity of the sewage treatment plant.
Yeah, based on these three methods.
Okay, okay, I'll explain this. See, these methods are population forecasting methods. These are
Okay.
not for capacity of sewage treatment plant. These methods are used to estimate, like suppose, see, if you are designing a
लाया
refill.
था उसके ला के किया क्या है तुम
Okay, ma'am. Suppose we are planning
Yes,
uh,
if
a
we are,
sewage treatment planning a sewage treatment from thousands of quarters.
yes, see,
So at that case,
See, like if you want to design a sewage treatment plant now for the year uh, 2022, then
Yeah.
the your design period is like it would serve only this year. Then in that case you already know the population of 2022 in a city, so you need not use any of these methods to design the population. You can directly use the population p in 2022, and then you can design. But we do not, as engineers, we do not design like that. We, if we are making a sewage treatment plant, we design it for a period of like this would serve for about 15 years or maybe 30 years. So if you are making something, then after 30 years, or after say if the design period is 30 years, and if of your sewage treatment plant, if it has to serve its purpose effectively after 20 years, then also it should serve the purpose. So in that case you need to know what is the amount of sewage that will be coming to the system. So for that, for knowing that sewage quantity, you need to know what is the population at that period of time. So
Okay.
for that, for predicting the population after 10 years or 20 years, you use these methods: arithmetic increase method, or geometric increase method, or incremental increase method, etc. Again, these are chosen based on the type of area where you are building. Like if it is a new city where there is massive scope of expansion and all, then it is prescribed to use this geometric increase method. And if it is a very old city where there is no scope of expansion and all, the literature is suggesting to use arithmetic increase method. So similarly other methods are also there. So this is how you select the method. So is it clear now?
Yeah, ma'am. If my population is fixed, suppose I am designing for 75 flats are
Yes.
there in one small societies. So
Okay.
my number, and based on that, my number of population is fixed. No, it
Yes.
is a small society, and they want to design a wastewater treatment for their society.
Okay.
So I can take an assumption, and because my number of flats are fixed, so that it will not be increased, and and based on that, wastewater quantities will be plus minus 2%.
Okay.
So like that, we can calculate, no?
Yes, if it is a fixed society where there is no scope of further expansion, where there is
Yeah.
no like much change will be happening in the coming years, then you can always go for that. But if you are
Okay.
designing for a city where there is a lot of massive scope is there for expansion, where there is number of people will be coming and all,
Yes. Yes.
you
Yes.
have to use these methods to predict the population
Yeah.
after your design period. See, suppose if your design period is 30 years, what will be the population in these 30 years? That you have to
Okay.
predict, and based on that, you have to design.
Mm. Is there any thumb rule to calculate the wastewater for the small society where the population is fixed?
No, no such thumb rule as such, as per my knowledge. But it is always calculated based on like there is per capita sewage generation, one fixed value is there. I guess it is
Mm.
135 LPCD or something. I'm not sure. I have to check it. So based on
Okay.
that and number of population, you can calculate it.
135 LPCD for one.
I guess so, but I am not sure about that value. Value needs
Yeah.
to be checked.
Yeah. Suppose thousand numbers.
Thousand.
Thousand. Yeah.
It is given in the lecture most probably 100.
Okay,
Yeah.
okay, it's 100 then.
And
Yeah,
then okay. 100 LPCD.
yeah.
So 100 into 75 flats, or 100 into 75, suppose four people are living in each flat.
Okay.
So 100 into 75 into 4, it is like that.
Yeah. That like that you can
Okay.
quantify the sewage generation.
Okay. Hmm. Okay, ma'am.
All right. Okay. Any
ठीक है मैम,
other
ओके.
question? Okay, then let us move on to next question. I guess some of your friends are still trying to join, so let us quickly include them also in the discussion. Okay, next question is which of the following population forecasting method is applicable to cities of moderate size and age? Option A, arithmetic increase method.
Option A, ma'am.
Let's see all the options. Option B, geometric increase method. Option C, incremental increase method. Option D, logistic growth method. Okay, you have said option A, right? Anyone else? Any other answers? Let us see the answer. It's option C. Option C is the correct answer. For cities of moderate size and age, it is incremental increase method. Option A is correct for old and established cities where there is no much scope of further expansion. As we have discussed, option B is for new cities. Option C for cities of moderate size and age. So these are the three in the example the professor has solved that one problem with these three methods, and we have seen that option A gave the smallest prediction, like the predicted population was very small, and option B, it predicted population to a very large, very high scale, and option C, with incremental increase method, the value was in between x and y. So this was seen in the example problem solved in the lecture video. So I guess it is clear for you now. So is there any doubt? Is there any doubt, anyone? If not, let us move on to the next question. Seventh question is, if arithmetic increase method is used for population estimation of small or comparatively new cities, it is generally expected to give A, correct estimation, B, higher population estimation, C, lower population estimation, D, none of the above. I guess we have discussed this now, so I hope that all of you know the answer by now. So what is the correct answer for this?
Option B, madam.
Option B. Any other
Option
name?
C, ma'am.
Option C. Yes, that is the correct answer. I guess we have discussed it in the before slide, before the previous question. See, the arithmetic increase method, it gives in the arithmetic increase method, the assumption is that population increases at a constant rate. So I think you would have seen it in the practice problem, how the variation is occurring after year by year, like how it is changing. So it is the method is developed based on the assumption that population increases at a constant rate. So always that if we use arithmetic increase method, it gives a lower population estimation. That is why it is said that it is best suited for large and well established cities where there is no further scope of expansion. So option C is the correct answer. Any doubt on this? If not, let us move on to the next question. The next question is, which of the following statement is incorrect? Incorrect. So option A, in demographic method, population is estimated based on annual birth rate, death rate, and migration rates. Simple graphical method gives accurate forecast of population. Accuracy of ratio method depends on accuracy of national population estimate. Option D, logistic curve method is applicable for very large cities. So, which could be the answer for this? Which is the
Option
incorrect?
B.
Option B. Any other lead? Anyone?
Option B, madam. Option B.
Okay, let us see the answer. Option B, yes, very good. Option B is the correct answer. Simple graphical method it do not give accurate forecast of population. You would have seen how the simple graphical method works. If not, kindly refer to your lecture video and lecture notes and kindly see the method, how they are interpreting the data and how we are predicting the population based on the simple graphical method. So in this method does not give accurate forecast of population. It gives very approximate results and should be used along with other forecasting methods. So I hope it is clear for you. Is there any doubt? Is there any doubt?
No, ma'am.
If not, let us see next question. Meanwhile, let me admit some of your friends again. Sorry for the interruption. Let us see the next question. The ninth question is conventional sewers shall be designed for a minimum capacity of option A 75 liters per capita per day or higher, option B 100 liters per capita per day or higher, option C 250 liters per capita per day or higher, 250 liters per capita per day or lower. So, which could be the answer for this?
Option C, I guess.
Option C, madam. 250 liters per capita.
Okay. Any other lead? Anyone has any other opinion? Okay, let us see the answer then. The correct answer is option B 100 liters per capita per day or higher. So option B is the correct answer. Again, this is a question where it is based on the how standards are designed or how what is given according to the CPHEO manual. So it is conventional sewers shall be designed for a minimum capacity of. So we consider many factors while designing the sewers. As we have discussed, we consider the population, we consider the sewage quantity generation, the area which is getting served, topography, etc. So after design, the code suggests that it should serve it should has a minimum capacity of 100 liters per capita per day. So this is the correct answer. So let us move on to the next question. I hope there is no doubt in this. So the next question is peak factor depends on option A density of population, option B topography of the site, option C hours of water supply, option D all the above. Any lead, anyone?
Option A, madam. Density of population.
Option A, okay. Any other guess?
Option D.
Yes. let us see the answer.
Option D.
Yes, option D. Option A, whoever has said option A is also correct. Option A is correct, option B is correct, and option C is also correct. So peak factor depends on all these three parameters: density of population, topography of the site, hours of water supply. So option D is the correct answer. Can anyone tell me what is this peak factor?
Maximum amount
Yes, yes.
sewage generation.
Maximum amount.
Of sewage generation.
Yes, you are on right track. Uh, any other suggestions? Peak factor, yes. Let us see the answer. The peak factor is the ratio of maximum sewage flow to the average sewage flow. You all know that there would be like sewage flow is not supposed to be a constant thing. It would vary based on many parameters, like the seasonal variation would be there. Even the in a on a daily basis it could change based on the timing, like there would be more flow in the morning, there would be less flow in the evening, like that it could change. So many factors affect the sewage flow. So we should while designing any sewer system, we should account for a peak factor. It is like design should be based on the um, like maximum sewage any sewer network could accommodate. So base for that we always come up with a factor called peak factor. It is the ratio of maximum sewage flow to the average sewage flow. So it depends upon these parameters. The peak factor is always designed based on density of population, topography of the site, and hours of water supply. So there is a thumb rule which professor has discussed in the lecture video. So I hope all of you are familiar with the thumb rule. If not, please refer to that. It is a reading assignment for you people. Please refer to the thumb rule for this peak factor. So any doubt on this? If not, let us move on to the next question.
Ma'am,
Yes.
any other factor is also included?
No, basically we have two terms, I guess: annual average daily flow and average 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 daily flow, and then maximum hourly flow, something like that. Two terms are there. For that we incorporate this peak factor. Maximum hourly flow is, I guess, average annual flow into 3 or something, so that I have to see again. So the peak factor is the important parameter which we consider to account for the variation in the flow. So kindly refer to this peak factor thumb rule from the lecture videos.
Okay, ma'am, thank you.
Yeah, thank you. Any other queries? If not, let us move on to the next question. So the next question is, which of the following is not true regarding master plan method? Again, this question is based on population forecasting method. Master plan method is one of the method for predicting the population. So, which of the following is not true regarding master plan method? Option A: city is divided into various zones such as residence, commerce, industry. Option B: population is estimated based on zone sizes and planned population densities. Option C: it is very easy to access the design population precisely. Option D: it is suitable for all type of cities, old as well as new cities. So, any answers? Anyone?
Option C.
Option C.
Option A, madam.
Option A. Then us see the answer. So the answer is option D. It is suitable for all type of cities, old as well as new. So this is the wrong statement. All other all other statements are right. So regarding master plan method, in the master plan method, as you would have seen in the lecture video, that it is a method in which uh, like if you have a city, you already know it would have been divided into various zones, such as this is for residence purpose, this is for commerce, then industry, like that. So various zones are already designed. It is a sort of a planned city. So this plan is like it is in the master plan method, it is also known as zoning method. So it has various zones already assigned. So the option A is correct. Then option B is population is estimated based on the zone sizes and the planned population densities, which is also correct. We already know the what are the various zones and what is the population in each zones, as you have already planned it. So it is the population is estimated based on those population densities in which this the zone is designed. So option B is correct. Then option C is it is very easy to access the design population precisely. Yes, that is also a true statement, because if you already have the answer for what is the population, what is the planned population density, and what is the population, then it is very easy to access the other parameters. So option C is also correct. The option D is it is suitable for all type of cities, old as well as new, which is a wrong statement, because in the master plan method, the city is already planned in such a way that it is already the different zones are already assigned for residence, commerce, industry, etc. So it is applicable to new cities, but not the old one. Old cities where we cannot have we cannot come up with a new master plan in which the city would be divided into different zones. So the option D is incorrect. Option D is the answer for this question. Any doubt? If there is no doubt, let us move on to next question. Next is a numerical problem. So I would want all of you to try this problem and kindly say the answer. The question is 1992, 2002 to 2012 and 2022 census data population is given here. So the what you would have to do is you have to predict the population for the year 2042, that is 2042, based on arithmetic mean method. So I hope all of you will try it now. So I'll give you a few minutes. Please try it out and please say the answer for this.
Option C, madam. 52500.
Okay. Option C is one suggestion. Any other answers? It's a pretty straightforward question. So I guess all of you can try it out and tell the answer soon. Okay, let us see the answer now then. I hope you would have done it by now. Option C is the correct answer. Very good. So let us see the detailed solution. So you have for year 1992, 2002 to 2012 and 2022. The population is given, and I will explain how this method works. So what you would have to do is, from this 1,50,000 to 2,10,000, the 60,000 is the increase. Then from 2,10,000 to 2,70,000, again you have 60,000 is the increment. Then you have to consider these two, and here you have this 1,05,000 is the increment from the year 2012 to 2022. So in this method, after calculating the increment from one year to another, or from one decade to another, you will have you will have a table of increments or increase, and from this you have to calculate the average. So this 75,000 is the average of these three. Then if you get this average, now you have to calculate population in 2042. 2042 means the latest data is available for the year 2022. So 2042 is 2 decades after 2042. So what you have to do is this population in 2022 plus, it is 2 decades after 2022. So 2 into this average value 75,000. So that gives the answer 5,25,000. Hence, option C is the correct answer. So this is what I have said. In the arithmetic increase method, this population growth is considered as a constant. So this is the 75,000. This method assumes that the 75,000 increment will be there after each decade. So this is how this method works. I hope it is clear to you now. If there is any doubt, you can ask. If not, let us see the next question. Next question is a theoretical question. Additional inflows considered in the quantity estimation of sewage are: first, A, inflow due to infiltration, inflow from commercial institutions, inflow from unaccounted private water supplies, all the above. Any guess?
Option A, ma'am.
Option A. Okay. Any other answers? Anyone?
Option B, madam.
Option B. Okay. Any other guesses? Okay, let us see the answer.
D.
Yes, option D is the correct answer. Additional inflows. You would have seen in the lecture video that, like, while estimating the quantity of sewage, other than the what we have estimated based on the design population and all, there could be other inflows into the sewer lines which should be accounted for while designing the sewer network. So let us see what are the additional inflows. So infiltration due to inflow due to infiltration, it is there. Obviously, it would be there. The second option is inflow from commercial institution. Commercial institutions like hospitals, schools, etc. Those things has to be taken care of. So that is also there. Then inflow from unaccounted private water supplies, which means that, like, suppose like in a municipal region, we know what is the quantity of water which we are giving into the municipal area. X is the water, sorry, W we refer to the pure water, and we would expect a percentage of this to be coming out as wastewater. But in addition to this, we would also have some other amount of quantity of wastewater which is getting generated, which we do not know where it is coming from, because we have not supplied that. This could be due to inflow from additional private water supplies. Some of the residences would be using some bore wells or something else to create more water, like allowances for groundwater should be there. So these things should be accounted for while estimating the quantity of sewage. Hence, all these three are correct, and so the answer is D, all the above. So, any doubt? Any doubt, anyone? If not, let us move on to the next question. So the next is a problem. I expect all of you to do this problem now and say the answer. The question is, if the development plan rules of a city provide following reservations for different land uses: roads 14%, gardens 12%, school 4%, and markets 3%, calculate the population density per hectare for the plan. Assume floor space index as 0.5 and floor area as 12 meters square per person. Option A 119, option B 289, option C 279, option D 256. So you have to estimate the population density per hectare for the plan. So I hope the similar kind of numerical was solved in the lecture video. So all of you please solve it now and please say the answer. I'll give you a few minutes.
Option A 119, madam.
Option A 119. Okay. Any other answers? Any other answer, anyone?
What is FSI?
FSI is floor space index. Floor space index means from the out of the total available area, how much is the actual area available for construction. So that is floor space index. It should be assumed as 0.5. So anyone is ready with the answer? Basically, you need to calculate population density per hectare. So let us see the answer. The correct answer is C 279. So let us see how this and how we arrived at this answer. We have been given the percentage of other construction activities like roads, gardens, schools, and markets. So total area available for residential development is, out of 100 percentage, this 100 minus 14 for road plus 12 for garden plus 4 for schools plus 3 for market. So out of this 100, only 67 percentage is available for residential development. So total floor area available for residential purpose, even though the 67 percentage is out of the total area available is available for residential development, we have to consider this floor space index for actually building the residential area. So we need to multiply this floor space index with this 67 percentage. So 0.67 into 0.5 is the actual total floor area available for residential development. So we have been asked to know the population density per hectare. So we know that like 10 raised to 10 raised to 4 meter square is 1 hectare. So this 0.67 into 0.5 into 10 raised to 4, it is the total area available, which is in meter square, for this residential development purpose in 1 hectare. And we are told that floor area is like 12 meter square area is being occupied by one person. So we have the total area available as 0.67 into 0.5 into 10 raised to 4. This much area is there in our hand for residential purposes, and we know that 12 meter square area is occupied by one person. So this much area divided by 12 meter square per person. So it is coming around 279 person per hectare.
1 hectare is equal to 10 to the square meter.
Sorry.
No. 1 hectare is equal to 10 to the square meter. The meter square 10 to the 4. 1 hectare.
1 hectare is considered to be 10 raised to 4 meter square. Any doubt? Yeah, that is how this we arrive at this answer. I hope it is clear for you. Is there any doubt? Any doubt, anyone? Shall we move on to next question? Yes. Anyway, all these slides will be uploaded. You can see the problem solving session part in the nptel course page. If you click on that, you will be directed towards a Google Sheet in which all these recording of this video will be uploaded along with these slides. So you can refer to these slides even after the class. If there is no doubt, let us move on to next question, which is the last question.
In a last video, has it uploaded?
Yes, yes, it is already uploaded. Even the recording is uploaded, and also the lecture note, this PPT is also uploaded. So in what you have to do is that there is a session called problem solving session in the NPTEL course page. You have to click on that, and then it will be directed towards a Google Sheet. So from there you can directly access to these videos as well as the notes. Okay. So let us move on to the next question then. There is no doubt. The last question is, average annual daily sewage flow of a city is 115 mld. The maximum hourly flow of the city, assuming daily and hourly peak factors as 2 and 1.5 respectively, would be option A 12,500 meter cube per hour, option B 17,525 meter cube per hour, option C 14,375 meter cube per hour, option D none of the above. So I would want everyone to try this problem and quickly tell me the answer.
Option C, madam. Option C, 14375 meter cube per hour.
Option C, okay. Uh, Very good. Let us wait for others also. Any other answer, anyone? there is no other way. Let us see the answer. The option C is the correct answer, which you have said, which is correct. Very good. Option C is the correct answer.
Thank you, madam.
Let us see the answer. Maximum hourly flow, it is based on the rule of thumb, which is discussed in the lecture note, that it is maximum hourly flow is 3 times average annual daily flow. The factors are also given here, 2 and 1.5. So the 2 into 1.5 into 115. 115 is the average annual daily sewage flow, which is coming around 345 million liters per day. Million, you have to be careful with the units here. Million liters means 345 into 10 raised to 6 liters per day. But you need the answer in meter cube per hour. So it is just the conversion into 10. It is 10 to the power 3 meter cube per day. 1 day is 24 hours, so 345 into 1000 by 24 meter cube per hour, which is coming around 14375 meter cube per hour. This rule of thumb is given in slide 30, page 15 of module 1 lecture notes. So basically what we have done is that we have the average annual daily sewage flow. As a rule of thumb, average annual daily flow into 3 will give you maximum hourly flow. The 3 is coming from this 2 into 1.5, which is already given as the daily and hourly peak factors, 2 and 1.5. So this is all about this question. Any doubt on this? Anyone? Any doubt? If not, let us conclude this session. I hope all the questions discussed till now in this session will be helpful to you for solving the assignment problems of this course, as well as for the final exam of this course. These are some of the questions which are developed based on the previous year questions, previous year assignment questions, as well as the exam questions, and also based on the lecture notes. So this will be useful for solving the assignment questions and also any other competitive exams which you will be writing. So I hope the session will be useful to you. And if there is any doubt or any questions, any clarification needed, you can ask now. Our next session will be on next Tuesday, 16th of August, same time, 7 to 8 p.m. If you have any queries of anything related to this course, kindly contact me in this email ID. And all the lecture notes and this recorded video of this session will be uploaded in the problem solving session part of this course page, nptel course page. If you click on that problem solving session, you will be directed towards a Google sheet in which all the lecture notes and all the videos are uploaded. So you can refer to that also. And in the last session, some of you have asked me that the final exam of this course would be objective or subjective. So I have asked that question. I have raised that query to the concerned authorities, and they have informed me that the exam would be of same sort as that of assignment. Like the exam would be objective in nature, not subjective. So I hope that is also clear now. So if there is any other query, you can ask me now. Otherwise, we would stop the session. Any queries? If not, let us meet on next Tuesday. Next Tuesday, I will be discussing week 3. I will be discussing questions based on week 3 NBTL lecture videos and lecture notes. So before attending this interaction session, if you could watch all the lecture videos and lecture note, it would be really helpful to you. If not, after the session also you can watch and learn. So that is there. So let us all meet on next Tuesday. So shall we conclude today's session? Okay, thank you. Thank you for attending the session. Thank you for your time.
Thank you, madam.
Thank you.
Thank you, ma'am.